Let's take a look at how to analyze a compound or reaction mixture by thin layer chromatography, or TLC. For this example, we have an unknown solid in this vial labeled unknown, and we know it's one of two compounds that we have a solution of. Okay, so let's take a look at how that works. So we need a chromatography plate, and I have that right here. It looks like a piece of paper or a card. There's a back that's plastic coated and a front that has silica gel adhered to it. It's a flaky substance. All right, so we'll start, and about 1 centimeter from the bottom of our TLC plate, we're going to draw a line, the baseline. We want it to be nice and flat, straight. Use pencil because pen can dissolve and travel up the plate. We don't want that. All right, so we have an unknown, and we're going to apply it to the plate along with each of our two standards. Now the standards are also solids at room temperature, but in order to get them onto the plate, they're dissolved in solvent. And these have been made up for you, standard 1, standard 2. So we need to first prepare a sample of our unknown and get it into solvent as well. All right, so I have another vial, and just going to take a little sample of the solid to be analyzed. Just a little scoop on the bottom of a scoopula. Put that in. Our main sample we'll just set aside. Now we need some solvent. And there's no need to measure, just use a transfer pipette. A couple of mils for that little bit of solid. Put the cap on, and we'll just kind of shake that to get it in solution. All right, so we need 3 marks. You can use X's or just little lines, and you don't want to press too hard because then the silica gel flakes off badly. Whoops. Okay, so I made 3 X's. I'm going to label one of them 1, one of them 2 for my standards, and the other one is going to be U for unknown. Whatever your labeling system is, that will be fine as long as you know which mark corresponds to which solution. Now we're ready to apply those solutions to the TLC plate. So we need capillary tubes that are open-ended at each end. Okay, you want to use a clean capillary tube whenever you put it in a solution. So a clean capillary tube for standard 1. So I just dip it in, and then on the 1 lane I just touch it down and a wet mark appears. Now we'll do the same thing for standard number 2. Clean capillary tube, just dip it in, a small amount is sucked up, touch it to the mark for 2. Now we'll set that standard aside. Now we're ready to apply our unknown solution to the TLC plate as well. So yet another clean capillary tube, dip it in, touch it to the plate. So now our TLC plate is prepared. Okay, now it looks like nothing's there. The little wet mark for the U is starting to evaporate. Other than that, it doesn't really look like anything. Okay, so this form of TLC works really well for UV active compounds. So if a compound is UV active and you've applied it to the TLC plate, when we shine UV light on it, it should fluoresce. So let me show you what that is. Before we've even eluted the plate, see how when I shine the UV light on it, we see those 3 spheres where we touched the sample? This is just confirming that I indeed got sample applied to the plate in each of my lanes of reference. But now it's time to elute the plate. We need a beaker that will hold our TLC plate, and then we need solvent in the bottom. You can change the composition of the solvent in the bottom, and your instructor may go over this more, or you may be told what solvent to use. For this example, I'm going to apply the sample to the beaker, add the sample to the beaker that we're going to use. And you just want to be careful when you're doing this. You can measure it 10 or 20 mils, it depends on the size of beaker. You want to add a small amount of solvent and then have a watch glass ready to cover that. But how I know I have enough and not too much is that the level of solvent is below my baseline. If I'd been careless and I had solvent above that, it's going to mess the plate up by dissolving my sample. Okay, so I've confirmed I have the right amount. So now, I just want to do this carefully and not drop my plate. Take that watch glass off, carefully put the TLC plate into the beaker, which is now my TLC vessel. Let it rest against the sides. Cover it with a watch glass. Now that wet line is traveling up, that solvent is being wicked up by capillary action. So after a few minutes, you can see that the solvent has traveled up, and we're about 3/4 of an inch from the top of the TLC plate, and the solvent is, I'd say, maybe 1.5 inches or 2 inches. So it's time to take this out, and you want to be ready to grab the plate, and before that solvent line evaporates, trace it with your pencil. And you can set it down and then you can press on it. So let's trace what we see. Now I've traced so I can see the dots without the UV light, and we don't need it anymore. Now qualitatively, we can see that our unknown lane matches up better with standard number 1. Those dots appear to have traveled the same distance, and standard number 2 traveled slightly lower. So TLC is really helpful in a qualitative way for this kind of identification. But of course, as scientists, we like to put numbers on data whenever we can. So we need 4 measurements. Okay, we need to measure with a ruler from the baseline to the solvent front. Doesn't matter what unit you use, I'm going to use centimeters, 4.2. And you can continue to write on the TLC plate if you want. That's one distance we need. Then we need to the center of each of those compound dots. Okay, do the best you can. If they're nice round circles like this example, that's great. If they're streaky, do the best you can to get the center of the main part of the spot. Okay, so then you want to measure from the baseline to that. So here we go. This one is 1.2 centimeters. Standard number 2 is 0.8 centimeters. And standard number 1 is 1.2 centimeters. Okay, you can also write those numbers in your notebook. And then with the numbers and a drawing of your TLC in your notebook, you're done at this. It can be thrown in the trash. So let's go over how to calculate RF from the TLC data. So standard 1, the spot traveled 1.2 centimeters, and we're going to divide that by the distance that the solvent traveled, 4.2 centimeters. So for RF, we have no unit, they cancel. This comes out to 0.29 for standard number 1. So let's just go through this for standard number 2, 0.8 centimeters divided by the same solvent distance. That comes out to 0.19 RF values. And the unknown, it happened to travel the same distance exactly as standard number 1, so it's going to have exactly the same RF value. Okay. If it was slightly less or slightly over, the RF value would be changed, but it would be a closest match to standard number 1. All right, so the spot distance over the solvent distance, units cancel, that's it. So after you're done with TLC, once you have all the data from the TLC plate, that can be thrown in the trash. Any spotters that weren't associated with the standard can just be thrown in the glass disposal box. And any solvent in the bottom of the beaker, that needs to go in the organic waste.